All right, so last time we learned this Friedel-Crafts alkylation. Let's go ahead and take a look at when it doesn't quite live up to its expectations. So first off, this has to be an alkyl halide, so it can't be any kind of alkene. So we must have a carbon that's an sp3 hybridized carbon attached to our chlorine. Right, so for example, if you try to react this with some kind of vinyl halide or a aryl halide, there's not going to be any reaction. And that's because, remember, we can't form it's disfavored to form a positive charge on an sp2 hybridized carbon. Another problem, although this one is really not that bad, is that it adds an activating group. Which we'll learn about a little bit later, but basically some substituents on our benzene ring can make the benzene ring more reactive by making it more nucleophilic, and an alkyl chain is something that can do that. So for example, if you added your alkyl halide and an AlCl3 in a 1-to-1 ratio, right? So for every one benzene ring, you have one alkyl halide. What you're hoping that you're going to get is just a mono-substituted benzene ring, but really what you're going to get is a di-substituted benzene ring, because this intermediate is more this product right here is more reactive than the starting material. However, like I said, this isn't really a big deal. We can easily fix this by just using the benzene ring in large excess, and then purifying off the unreacted benzene. So that's not really a big deal, but just something to be aware of. The really big limitation of these Friedel-Crafts alkylation reactions is carbocation rearrangements. Right, so we've seen that we have a carbocation in our mechanism. Anytime you have a carbocation, you can have carbocation rearrangements. And remember our rule, if a carbocation rearrangement can occur, it will. So let's think about adding this alkyl halide with our Lewis acid catalyst. So the first step that we're going to have here is our formation of our activated compound, our activated electrophile. Our chlorine is going to attack our AlCl3. Note that previously what we had was just this alkyl halide leave. And in this case, then it'd leave a primary carbocation behind. Primary carbocations are big no-nos, so we shouldn't have any primary carbocations in our mechanism. However, just because we don't explicitly have that doesn't mean that rearrangement can occur. It still can occur, right? A carbocation here in this primary position would be very unstable, whereas if it could move down to this tertiary position, that would indeed be quite stable. So what we can have here is essentially just a hydride shift, right? Remember that from CHEM1. We can have this carbon-hydrogen bond shift over onto this position and then kick off our AlCl4. And so then this continue on to give us our product. Right now, our benzene ring is going to go ahead and attack our electrophile and so on and so forth. But you can see, while you may have intended to insert our benzene ring right here, some rearrangements can occur. So here's that reaction with the product. Right, so what you're actually going to get is this product instead. And this occurred through a hydride shift, right? The movement of that H. But with the carbocations, alkyl shifts can also occur. So for example, if you had this alkyl halide you may get an unexpected product, which would look like this. And this will go through an alkyl shift. The mechanisms will be in your work along. So definitely try to get the product there. The last thing that isn't quite very good with these Friedel-Crafts alkylations is that they don't work with moderate / strong deactivating groups. And we'll learn about what that is later on. But for right now, we're just going to call it an EWG, an electron withdrawing group. Basically, if you have one of these and you try to react it with your alkyl halide and your AlCl3, you're not going to get any reaction. The exception is halides. So it'll still work with a bromo or a chloro. But like I said, we'll learn about what electron withdrawing groups here are shortly. So while the Friedel-Crafts alkylation might seem super useful, it does have a lot of drawbacks, but don't worry, we've got another reaction that solves most of them.